Last problem for the review, problem number 8. So this problem on the test would probably be buried in some kind of context in a word problem, but the key thing to recognize here is our constraints are in terms of less than or equal to or greater than or equal to, so therefore this tells us it's a linear programming problem. And how we do those, we graph our constraints, graph all of these, then find the feasible region, find the corner points, substitute those into the thing we're trying to min or max, see which one gives us the desired quality. In this case it's a min. So here we go, we have to graph. Now, as I recommend, graph, sketch, just a quick sketch, don't make it pretty. All we got to do is find that feasible region. So I also recommend to graph lines using the intercept method. So very quickly, find the x and y intercepts for each of our constraints, and then we will quickly plot these. So there we go. There's each of the x and y intercepts. So now when we go ahead and sketch these, I also highly recommend, notice I kind of tipped you off with A, B, C. I would recommend labeling them on your sketch. So for the first equation, I'll do this one in red. The points are 0, 42, and 12, 0. So there we go. So that would be equation A. The next, and notice it's greater than or equal to, so I use my test point. Test point is 0, 0. So if I were to substitute in 0, 0, that would be 0 plus 0 is greater than 84. False. So we're shading up. Okay, so we'll worry about that in a second. But anyway, so the next equation, I'll do this equation in blue. This gives us 0, 30, so it's below that one, and then 20, 0, so beyond that one. So this equation, equation B, in blue, goes there. And again, test point 0, 0, greater than 60, that's false, so it's shading up. Last but not least, we have third equation. So that one is 0, 12, that's below the others. And then 24, 0, so that one goes right there. So now the question is, we just need to make sure it's crossing in the right place. It should not be crossing above the intersection of A and B. It should be crossing below A and B. And we can actually do that throughout this process here as we do our work. So our shaded region, the solution region, would be above all of our lines. So if I was asking you for a max, we'd need to be concerned because notice the thing we're trying to the objective function, they're all positive. So therefore there is no limit to our maximum, but there is going to be a minimum because we do have a limit to our bottom. So we need to check these points, all of these corner points as we move along the graph. So we need to check the point 42, 0. Oops, here. Maybe I'll make a list over here. We need to check 42, 0. Excuse me, it helps if we actually know how to read a graph. 0, 42, there we go. We need to check this point down here, which is 24, 0. Now, the other two are in the middle of the graph, so I need to know how to find these. Well, that's why I recommend labeling all of your equations, because now it becomes rather simple. This point right here, the one where the red and the blue meet, well, that's just equation A, equation B. So I can take equation A and fill that into a matrix, equation B, fill that into a matrix, and let the matrix do reduced echelon form and spit out the answer. And when we do that, we will get the values of 6, 21. So what we can see now is that the y value of that point is 21, where on our C graph it started at 12, so we do have it sketched correctly. Because it is below, the highest it ever goes is 12, so therefore it has to be below 21. So now, the next point we need to find, the last point here, is where the blue and the green meet. Well, the blue and green are just B and C, so we just throw those in a matrix and let it solve it for us. And then we get, when we do that, we get 18, 3. So now we take each of these points and evaluate them for C. So when I substitute in all these values, I get, well, for the first one, when I put in 0 in for C, C equaling 2xy, the 0, that's easy, it's just 42. and my goal is to minimize. So now when I put in 24 times 2, that makes 48. That's not a minimum, so I throw that one out. Now I substitute in 6 times 2 is 12. 12 plus 21, that makes 33. That one's better. Eliminate that one. And then last but not least, 18 times 2, that's 36. Already too much. Eliminate that one. So therefore, I know I have a min of 33 at 6, 21. Okay.